the site, so maybe there's something. Oh, I forgot to hit the go live button. Now we should be live. I forgot to hit the go live button. So many buttons I need to click to get things going. Sorry about that for those hanging on there for a couple of minutes. Now we're actually transmitting. Let's see. I see Abu Bakr. Welcome back, Abu Bakr. I see Bad Gessen. Welcome back, Bad Gessen. I see Saeed. Welcome, Saeed, to Office Hours, Unit 2 Office Hours, Week 2, second Office Hours of the week. So 222, I guess, Unit 2, Week 2, Day 2 of the week. And our goal, we had some good conversations last time. I think it's about time we crack open the mini projects. A couple of announcements I have to give is that next week I'm going to be out for 2 days. Monday and Wednesday. We will have another instructor who will fill in for me for those 2 days. Next week, Monday and Wednesday, I will be out. A different instructor will take my place for just those 2 days. But because he's kind of fill in, it's going to be a different time. So Monday, Wednesday, office hours will occur at a different time. It will occur at specifically, it's going to occur at it's 8:30 a.m. East Coast, so I think that corresponds to 12:30 UTC. We will make sure that we make an announcement on the board. I will send an email out and make sure on the Jupyter Hub the actual new time will be posted. So just next week, I'm going to be out Monday, Wednesday. A different instructor will fill my spot, but it's going to be a different time. So don't be thrown off by that. It will occur at 12:30 UTC. All right, we got Sulaimanis here. We got Ramsey. Welcome back. And let's go ahead and crack open our mini project. Let's go ahead and start making progress on the mini project. Do kernel, restart and clear output. Okay, so let's go ahead and run the top cell, run the second cell, and get things going. Let's go and run this cell here, which will download the data if we haven't downloaded it. Let's import our customary packages like np and pandas we'll probably have to invoke. And let's look at the data we're working with here. And let's go ahead and just process some data. So it's just getting our data set up. Not really concerned about that. So let's go and look at what Q1 is asking us for here. So, Center for Medicare and Medicaid Services imposed regulations on nursing homes. I see Fatima is here. Welcome back, Fatima. However, nursing homes are inspected by state agencies for compliance and regulation, and fines for violations can vary widely between states. So it's really while there might be federal, so nationwide regulations, it looks like it's really the states, the individual states in the U.S. that regulate these nursing homes and thus impose the fines. So these fines are going to vary widely across each state. And what we want to do is let's go and develop a simple initial model. Sometimes it helps that we come up with a very simple initial model. It's not going to be our final model, but it's a simple model for us to get familiar with the data, to work with the data, and can serve as a benchmark when we try to improve the model. So we're going to have a very simple model here that is just going to rely on the state a nursing home is located in. So in other words, what we want this model to do is going to accept some data about the nursing home. So it's going to accept some data regarding the nursing home. Can't spell nursing home today. And use just the state to predict the fine. See Emmanuel and I see Mickey Rat. Welcome back, Emmanuel and Mickey Rat. So we're going to accept some data about the nursing home, and it's going to use just the state to predict the fine. So specifically what it's going to do is we are going to train our model. We are going to train our model to learn, I'll put that in quotes, to learn the average fine for each state. So that once we know that average fine for each state, we use that for the prediction. So for example, if we have our data set and we learn that Wisconsin, the average fine is, let's say, $1,000. I don't know if that's even in the right realm, just for practices, just say the average fine is $1,000 in Wisconsin. So if we want to make a prediction for Wisconsin in our, let's say, test data, we will use that mapping. We'll use the average for each state to make a prediction. So every time we see Wisconsin, we're going to predict 1,000. If we learn that in Vermont, the average fine is $500 from the training data, that means that every observation, we're going to predict 500 for Vermont. If a nursing home is in Vermont. Okay. So that's what we want to do. And we actually have some template code here called Group Mean Estimator. Take a look at the chat, what's going on here. I see someone asking me, you try to connect. We'll link in. I couldn't find the connect button, and your message option also seemed accessible only to premium users. It's a little weird, and let me go ahead and see if I can, let's see if I can fix that. If you can send me a message, try to do that. Try to send me a message. Let's see if we can connect via that way. All right, so I see that Taiwo has a question. Go for it, Taiwo. Let me know your question before I proceed. So what I recommend is that we sort of, before we dive into the class, let's first do it sort of outside of a class, just so we know how it works, and then we can go ahead and put it into the class. If I have a data containing date feature, how do I encode it? When you have a column dealing with date features, you typically can convert it into how many seconds since 1970, an epoch. Or if you have two date columns, you can take the difference between them and convert them into some sort of unit of time, the time elapsed between a date. So essentially what you want to do is convert that date into the time elapsed from some sort of starting point. That starting point can be arbitrary, let's say January 1st, 1970, or there can be a second column that you can calculate the difference, or maybe for your process it makes sense that you calculate the date from some sort of starting point. So that would be my overall prediction there. And we'll talk about dates later on in this notebook. So let's go ahead and look at this. So we have our data. What do we even call our data? We called it data. And there is our data frame. So we have a column called state. And what should I do? It's a pandas data frame. So what should I do if I want to calculate the average for every state? How do I go about doing that? Let's have a pandas data frame. How would I go about calculating the average for each state? Yeah, group by, exactly, right? So I can take my data and I can call group by state. Exactly. But the label that I want to calculate the average from, the label is not in this data, I don't think. Because we are trying to predict the fine total. Exactly, by the guessing. Exactly. So that's a little annoying. So I want to add, if I look at fine totals, there's the fines there. So what I want to do is I want to go ahead and take my data set and create a new column called Y. Assign Y equal to fines total. So I know I've added that column to the data set right there. So what I can do next, the reason I'm doing this is because I can group by state, and then calculate the average of y. So I can call this result, the proverbial result, and I've got my result right there. So this is a series, right? This is a pandas series that tells me the average for each state. So you can imagine that I need this piece of information for me to come up with the prediction. So since I need this piece of information to come up with the prediction, it's going to be reason that this piece of code here should belong in the fit method. That any custom regressor we create in scikit-learn, that this process here should reside in the fit method. Alright, I see Taiwo's got something like 2022-06-19. Okay. And is there a logical start point? Is there a logical start date? Because if there's a logical start date, then you can compute the differences and calculate the elapsed time. So now I calculate this result here. And now what I can do next is I can say result. I can locate, let's say, Wyoming. And I get the average for Wyoming. So now what I can go ahead and do is I can go ahead and take this process, called it result, but let's put in the fit method. So here data will be called X, and we calculate the result, but I'm going to call this a better name, right? Perhaps it's a better name, and perhaps a better name here would be something that conveys state average, right? State average might be a good name. However, I'm going to call this group average, because when someone creates an object of this class, they specify the group. So I should probably say self.grouper. And grouper is kind of a weird name. So maybe just call it group. I think group would just be a better name for it. So this will calculate the group average. And I should probably store this as my group averages. There we go. So what I've done here is I have the code that's going to take the dataset X. It's going to put the Y column so that I can group by whatever group I'm grouping by and calculate the average. And then I'm going to store that as an attribute which I can then invoke in the predict method. So let me know if you have any questions here, because the next thing we're going to do is we're going to flesh out the predict method. I see, I'm going to take a look at the chat here. I see Burke is asking, I got a quick question. I completed previous term module 2, but I lost my Jupyter notebooks. Can you provide me with the notebooks again? I really want to practice what I learned. I cannot, unfortunately, I cannot give away notebooks. You have to be a student to do that. So unfortunately, just the restrictions that we've got, I cannot just say, here are the notebooks. Have at it. Unfortunately, I cannot do that. Any questions people have about what I've done so far in the fit method? Sorry about that. At what point do we decide to convert the data frame into NP array, or do we just do transformations on the fly? I would typically what I recommend is that if you have data, it's probably easy if you convert it into a data frame. So at what point do we decide to convert the data frame into a NumPy array? And scikit-learn likes NumPy arrays. It likes NumPy arrays, but it can accept data frames at times. So usually what happens in a scikit-learn transformer is that if you use a built-in scikit-learn transformer, you can give it a data frame, but what comes out is a NumPy array. So what I recommend you do is that sometimes it might be easier to work with a data frame, that your very first transformation step is a conversion to a data frame. The very first transformation step can be a conversion into a data frame. So in fact, we haven't done that. We haven't done that here. We assume the data is going to come in as a data frame, but you know what? It's probably better that we construct a custom transformer that will convert into a data frame. Because the grader is going to have a list of dictionaries as the input, a list of dicts, which is a little annoying to work with. We understand if we had a data frame version, it's a lot easier to work with. So why don't we just have a custom transformer that would take that list of dictionaries and convert it into a data frame? So then the next step we do is give it downstream. So I would put it in part of my pipeline. Because if I put in the pipeline, then I don't have to worry about doing it outside of my pipeline. I can just let it do it in the pipeline. And that first transformer can be just simply a check. If it's already a data frame, just keep it as is. If it's not, do the conversion. What does base estimator and other modules imported do, and why we have used them as parameters for the first class? Yeah, so very rarely do you want to create a transformer or an estimator from scratch. So you don't want to create a estimator from scratch. Instead, what you do is you apply inheritance. Inheritance. And what we mean by inheritance is this class we are creating is not from scratch. Remember in the Unit 1, that VC mini project, that class we created, that point class or vector class, whatever it was made from scratch. It was not built on top of something else. Here, we're building this custom estimator, this custom regressor, from the base estimator class and the regressor mixin. So it's going to inherit all the methods and attributes of the two parents so that we don't have to code those methods. So in order for this class to work well in the scikit-learn ecosystem, remember the tools of scikit-learn like pipelines, grid search CV, things like that. Those tools, in order for it to be properly working with these tools, we got to make sure it's going to inherit everything from its two parents. So that's why we do that. All right, glad that worked out, Fatima. Let's see, what is the rationale behind removing find total from the data frame in the first place? That's a little peculiar, right? That's a good question, right? So notice that we removed it. We removed the label. Originally, removed the label from the data set, and then here we glued it back on. And you're like, wait a minute, you removed it, you separated it, and then you glued it back on. Well, we're kind of forced to because of the idiosyncrasies of scikit-learn package. In scikit-learn, when you predict in scikit-learn, when you use fit and predict, the labels must be in a separate data structure. That's just how the package works. It has to be X and Y separate. So it's a little annoying how we popped it and then in the internals we glued it together. So we just had to work around this paradigm. We had to work around the API of scikit-learn. When we call fit and predict, X and Y need to be separate. So it's a little bit of the idiosyncrasies, the peculiarities of this package. Once X and Y is separate, of course we want them in together internally, so we'll do that internally, but scikit-learn is none the wiser. All right, should we generalize Y equals total fines? Oh, yeah, yep. This is just a mistake when I copy and paste, right? I always forget to change things, so exactly, right. If I want to be fancy, I can call this target if I want, but yeah, you are correct. Who was that? Too about it. Ramsey, yep, you are correct. Sorry about that. Now I don't have a global, right? I'm not, yeah, good call there, good call. Thank you for catching that. There are no redundancies. Okay. Other questions people have of what I've done? Okay. So I'm going to back up and say, you know what? Maybe it would have been better if we had a custom transformer that actually converted a data set into a pandas data frame. Because our method here, this assumes that we are working with a pandas data frame. And I guess we could have the conversion in this method, in this estimator, but that's not good programming practice, right? We want separation of concerns. Why should we have why should we worry about for everything we craft, for every of these predictors, that make sure it's a data frame, make sure it's a pandas data frame? That really should belong as a separate class, a separate transformer, a separate step. So that's what we'll do here. We'll say class, we'll say from sklearn. We'll just go ahead and copy this here just in case we can have it right before. Let's create a custom transformer. So class, I'll call this toDataFrame base estimator. But since a transformer is going to inherit from the transform mixin. And the fit method will accept X and an optional Y. And here we ask, so here is anything we need to learn, from the data to transform it. That's the question we ask. Is there anything we need to learn in the data set for us to transform, or in this case to make it into a data frame? Yes or no? And if yes, what is that? What do we need to learn from the data? Is there anything in the data we need to learn, calculate, derive, to apply the transformation? Well, the averages are done by a different estimator. The average is done by a different estimator. We're doing separation of concerns. We're talking about this transformer here, the toDataFrame. We're dealing with the toDataFrame transformer. This here is actually a predictor, a regressor. We're talking about this one here. This is going to convert a data frame, sorry, it's going to convert a data structure, a list of dictionaries, into a data frame. Is there anything we need to learn from the data to apply this transformation? Yeah, nothing, right? Exactly, Swimming. There's nothing we need to learn in the data to make the transformation. So we'll just say return self. We cannot forget about returning self, because the reason why we need to do that is because in order for this to work well in the scikit-learn infrastructure, it needs to return self. There's a lot of key assumptions the code base makes that will break if we don't return self. So just one of those things we got to remember. I'm going to define the transform method, so self and x, and this is where the actual transformation occurs. This is where the actual transformation occurs. And what we got to do is we got to first check if it's a data frame. If it's not, we convert it into a data frame. So what I can do here is in Panda, I can use the is instance. So for example, let me just play around here. Is instance, and I can give it the object, let's say data, and check if it's a instance of data frame. I get a syntax error because I forgot a comma right there. It's true. So I can just say here, if is instance data PD data frame, in fact I should say if not, then we need to convert it to a data frame. So return PD data frame of data, else return the data, which is called x. Sorry, it's called x. So we got to make sure I call that x there. And now I can go ahead and create the object. Attribute error, no transform, because of a typo. And there we go. Let me see a question here. Don't we need to declare the init? No, we don't. No, we don't. We confusingly don't need to define the init method. We don't have to. And the reason being is, well, let me throw you this. Why do you think we don't have to define the init method? What do you think is happening that allows us not have to define it? In this case, we don't. You can argue we don't need it, but why don't we need it to define it? There's nothing we need to, no attribute we need to initialize. But why can't we get away with it from just omitting it in the class definition? Inheritance, exactly, an inheritance. Exactly. So it's inheriting from the base estimator, so we don't need it. So we can just keep it what it inherited, and that's perfectly fine. If it had to do something specialized, like there were some additional things we need to associate with it, exactly, inheritance, yeah, exactly, right? Key concept bringing in from Unit 1. I always like to make connections back to Unit 1. Exactly. All right. So we got that. So we took a step back and we have a custom transformer that will simply take a data set, check if it's a data frame, and convert it to a data frame if it needs to. So now we can have a two-step process. Now we can have a pipeline. Okay, and let's go back to here, right? We haven't fleshed out the predict method. Forgot about fleshing out the predict method here. So in this example here, I've got to use, here, I'm going to use self.groupAverages to determine the predictive value. Should the data not be X? It should be X here, because usually we define the transfer method. It's a strong convention. We call the data X in the signature and in the internals of the method. Right? What we actually give it is called data, but the function signature we're going to stick with X, which is a strong convention in scikit-learn. It's kind of what we did here, X and Y, so we made sure it was X and Y. So now what I can do is I can say, well, for X, and X here is going to be a data frame, so I can probably get the states. X is data frame, I can probably get the states by doing self.group. So this is a series of states, and what I could do, I can say for state and states, I can then pull it out, self.group averages, lock, and state, and return that instead. So what I've done here is I'm going to iterate through all the states contained in the data and take each one and locate the proper one in this averages series. And I think this should get me the answer, but let's experiment. What I call it, mean group mean estimator. And let's predict on data. And I come up with a set of answers. They appear to be all the same, so maybe not the... Oh, they're different. They're different. Okay, they're different right there. Okay. Looks like it's doing something. All right, that's not too bad. Going back to Taiwo's question. Back to the transform. It should be X, right? It should be X because we've defined what comes in as X, so we got to make sure that whatever we work on is also called X. So we're okay with that there. So I think the regressor works. So let's go ahead and try it out. Our pipeline is the first step we're going to go ahead and do is the conversion, the to data frame. I see this SME. I don't know what this means. SME, this is not very readable. So let's just have the courage to fix that. Let's call it regressor because that's what it is. In the to data frame, we call fit. We get a syntax error because I forgot to put a comma right there. It even tells me, perhaps you missed a comma. Nice enough to tell me what my mistake was. I got a different error because it's actually what grouper is, right? Grouper is a weird word, and I feel free to edit what we write. So oftentimes what we suggest isn't the best thing to do, frankly speaking. I'm going to be a little bit fixed to formatting here. I think that's fine. There we go. So now I take a sample. Okay, that seems to work. And if I give it an observation where that doesn't exist, I get an error. I'm getting an error. So I get a key error. Okay, so questions right now before we try to fix this problem. Okay. So obviously I have a problem here. It looks like my model cannot make predictions for observations that belong in a state that was not in my training data. Right, where did I put the fitting? The fitting was right there. Right there. So let me look at this code here, and what are some suggestions on to improve on this code? As always, we want to take a step back and analyze and critique the code we have. So what is your criticism, your critiques on the piece of code we have here? There's at least one thing that comes into mind that I just don't really like. We can use try and accept to handle those that are not in the data. Right, we can use try and accept. That's one solution. And that would look like, if I were to sketch that out, we can go ahead and sketch that out. We can do something like a try. I can come up with a list called predictions. It's empty, and say I can say for state and states, I try to do predictions append self.group averages .lock state except a key error, and then I append some other value. What do you think would be a good value to append? I get a key error. I still have to make a prediction. What would be a good value to use instead if I don't have it? I gotta predict something. What would be a good value to predict instead? You gotta make sure I return predictions, right? Make sure I return predictions. Any good guess? Right, we got to predict something. What do people recommend? So we are using try and accept, right? We're going to try to do this and append a value, but when we have an error, a key error, when it doesn't exist, we got to predict something, right? We got to append something to that column, because if we don't, then our answer is short. In fact, right? We have to come up with one prediction for every observation. We got to come up with something. I'm going to put 0 in the meantime. So now that this should work, it won't cause a key error. Let's go through the rigmarole. I get a value. I can give it to the predict method. I can give it to the grader, and the grader does I get a decent enough job to get above 0.9. But I would argue that maybe 0, while will prevent an error, maybe is not the best number to predict. Let me ask you this. If I wrote someone's name down, on a piece of paper, and I told you, tell me how old you think this person is. And let's say there's nothing about the name culturally for you to identify how old they can be. I know at the very least, I know in the U.S., and this is not unique to the U.S., there are some names that are just old-fashioned, that, like Gretchen, Gertrude, names for, who are just not as popular these days. So if you see someone with that name, they probably are older. And there's some new names out there that are more popular amongst younger people. But let's say there's nothing culturally we can pick up from the name to clue us in on how old someone is. Right? A random name, no cultural clues or keys. How old would you guess that person to be? Would you guess that they're a newborn? Or would you guess something else? Yeah, generally mean for maybe the mean for whatever state they reside in, the mean of the country, right? Predicting that they are a newborn isn't the best thing to do. So while it can give us an answer and give us something to work, there's a better prediction out there. So maybe what we got to do, we'll put a comment here and say if some state does not exist in our training data, we got to predict something. Perhaps a good guess is the global average. So perhaps a good guess is the global average. Whatever that global average is, that's what we should predict instead. We probably get a better result. So now there's another piece of information that I need to come up with a prediction. Where in my class definition should I inject the code to calculate the global average? Where does that belong in my class definition? Where would that belong in my class definition? To compute the global average, for thus we can use it to come up with the prediction. Where would that fit in? In the fit method, exactly. Because remember, it's in the fit method where we put the logic, the code, of all the things that we need to come up with a prediction. Right? That's what it means to fit and train a model. The model isn't actually learning anything, right? It doesn't have sentience. It doesn't really learn in the same sense we do. What essentially learning does in machine learning is just basically calculate parameters. Calculate parameters that are then used for prediction. So sometimes I've been actually giving people recommendations that you maybe want to write your predict method first. Because when you write your predict method first, then you know what you need, so that will infer what you need in the fit method. So here, if we take that strategy, I would say, well, I need self.mean. And well, I need the mean, well, maybe I get it from here. So maybe I'm going to say self.mean underscore is, if y is our label, we'll just calculate the average of that. It should be a NumPy array, I believe, but let's just make sure, and I call NP mean. So here's my average, the global average, and then 9 gets invoked here. So let's try that out now. We get a prediction. Now it's not 0 anymore. Let's see what we get. We get a score of 1. We get a better score now. We get a better score. I was going to ask about a mean, but here we are. Okay, well, now we got a better score. What if we put an NAN value? Well, we're going to get an error because we need some prediction. We need some sort of prediction. So we're going to give our best guess, which is the global average. So I see a question here, sir. I still don't know how to see what the model learns. So what the model is, quote, learning here is it learns the average for each state. It learns the average for each state. Then it uses the average for each state to come up with a prediction. And that's what the model is learning. Yeah, so when you ask what the model learns from the data, I have no idea. Yeah, so maybe the best thing to do here is to write the predict method first. It's a little bit radical, right? How do you make predictions without fitting? But if I told you create a custom regressor that makes predictions by using the average of each state, when you code up the predict method, there are two things you'll find that you need. You need the average for each state, and you need the global average. Since you need those two things to come up with a prediction, that's what you got to learn and calculate in the fit method. So that's what the model needs to learn. So maybe it's better that we first write predict, figure out what we need, and that will guide us in how we define the fit method, and going to guide us, dictate to us, and how we craft the fit method, what the model learns. Maybe that's a better perspective. Is it standard practice to try 0 NAN, mean, median, pick the best, or is there some other logic involved? So we don't want to predict 0 because if I don't know someone's age, predicting they're a newborn is not a good guess. I got to come up with predict some value. So NAN is not a number, so we'll omit that. So mean or median, right? Mean or median, right? Perhaps median will be better. Median tends to be generally do better. But we only really know until we actually do the results. So it's mean or median, and it's one of those like you can nitpick which one you think is better, but you're sort of focusing on a less important feature in the model. Yeah, we'll play with imputers who have missing values in the data set. So exactly about the guessing. All right, it looks like Fatima. Looks like that you like that approach. Okay, yeah, maybe it makes more sense, right? Figure out what you need and then build from there. And that's what it learns. If we were to scale the data, would you typically scale the entire data frame including Y, or would you exclude the target? You would exclude the target from the scaler. That is correct. We don't really want to scale Y. We don't really need to scale Y. So that's another reason why scikit-learn keeps them as separate data structures. It's going to keep them separated. If you want to glue them in because you have to, like in our case, we did. But that's sort of the advantage of having us two separate data structures. So keep in mind the NAN situation here is a little different. We have missing values. We don't want to have missing values in the prediction. We might have missing values in the data, in the X, but not. But in this case, it's a little different. We don't want to predict NAN for our labels. Okay. So I'm looking at this, and there is something that I still don't quite like. Still don't quite like. What do you think that is? think there was something I could have made my life a lot easier with. Some smell in my code, if I can use that phrase. I'm not happy with it. Maybe I'm being very picky today. Gets me the right solution. So I got correctness, but maybe there's something could have a better design. I could have better designed this. Should we use num? Yeah, so notice how we're creating a Python list, which is fine. It's fine, and when the list is a 1D array. But why aren't we using NumPy? Right? Why aren't we using NumPy? Maybe we can use NumPy instead. And related to that is, there's some alarm that should be going off in my brain. An alarm that we've installed in Unit 1. The fact that I'm writing an explicit for loop. I'm writing an explicit for loop, which I find a little annoying since we're in Pandas. Shouldn't we be doing better than writing explicit for loops? So it's probably, I can still do comprehensions, but that'd be still a for loop I'd be concerned. So there's probably a better way I could have written this. Probably a better way, right? Yeah, comprehensions would have been nice, but even better, right? So let's explore that. I see a question here about feature unions. Feature unions are a way I can combine the output of transformers in parallel. That's what a feature union is used for. If I have several steps that need to be conducted in parallel, I need to glue them together, glue their outputs together. Feature union would be helped out. We're going to see feature unions as we go through this mini project, so we'll get more involved there. Yeah, so maybe PD apply, right? So maybe what I should have done instead is this average is a series. Maybe I should have converted it into a dictionary instead. Right, so maybe remember what I said? I said data, what do I call that? Result. Right, there's a series. Can I convert it into a dictionary? Oh yeah, I can convert it, I can call the toDict method to convert it into a dictionary. Okay, maybe that's convenient. Let me try that. And I can say toDict. Now it's a dictionary, so maybe that's a lot easier to work with. I'm going to go ahead and rename this. I'm not going to delete it. I'm just going to name it something else, _predict, and then define my new predict method. So let's go ahead and fix issues. So I can go ahead and do something like x. So, well, let's actually do it outside, right? Let's do it outside. I can call this group averages. Let's do this outside of the class just to nail down the logic, and then we can go ahead and put it in the class. So I can go ahead and get state, and what I can do is I can do something like apply, right? Apply, and my function is take a value and look it up in the dictionary. Group averages x. Oh, and that's a series, right? That's a Pandas series. Awesome. The other thing is, well, we have a get method. Remember, we have a get method. We can say mean underscore is equal to find totals mean. So we can use get and say get me the key, but if it doesn't exist, use this other value as default. Oh, that's pretty nice. That's pretty succinct, right? I'm using dictionaries and I am not writing explicit for loops, and I get a panda series. So I solved 3 issues right now. Solve the fact I'm writing an explicit for loop. That's probably the best goal. I have a better data structure of a panda series, which is probably better than a list. And I'm avoiding the try and except by using the get method of a dictionary. So now let's take this here and let's flesh it out. I can say self.group apply lambda x, and I can do self.group averages and give it x, self.mean underscore, and that's what I'll return. And I will just go ahead and break this down into multiple lines just to, I guess, show off. I call values because it gets me a NumPy array if I want that instead. And now that's my predict method. Let's see if it works. Get a type error. A dict object is not callable, so apparently I'm trying to call a dictionary. Maybe I can fix that. Oh, get. I forgot to call the get method. Okay, well that seems to work. I get NumPy array. I get a score 1. Oh, I don't know about you, but I prefer this. I prefer this. It's a lot cleaner, right? So I cannot stress enough. You get the right answer, you get your logic down, and take a step back and critique yourself. See, how can we improve this? Questions people have. Questions about what we have right now. I'm satisfied with what our final solution. At least I'm satisfied. Not saying that. Not saying if I'm satisfied, that's good to go. Maybe you're unsatisfied, but at the very least, I'm satisfied. Okay. I'm happy. I think it's a good place to conclude for today. Right. Even with Q1, I feel like we learned a lot. I think we learned a lot in Q1. We'll go and pick this up tomorrow. Is there a scikit way to do this? No, right? You mentioned last week that we should be switching back and forth between NumPy, PD, and CKey. We shouldn't be switching back and forth between NumPy, PD, and scikit-learn. I'm not sure if I recall if that's exactly what I said. I think what I was advocating is that we should build any custom tool we build should be done in the scikit-learn ecosystem. So we should rely on creating properly classes. The internals should still rely on NumPy and pandas. What I want you to avoid doing is sort of one-off transformations outside of the idea of transformers. What I'm trying to avoid you to do, or best practice, is to avoid doing any type of processing and transformation outside of transformers. The internals will be using NumPy and pandas, which is exactly what you want to do because these tools are built with those two tools in mind. So the internals will still rely on NumPy and pandas, but they are encapsulated by scikit-learn. So we can then, the tool we create, this custom transformer, custom estimator, custom regressors, are going to be compatible with pipelines, grid search CVs, feature unions, all those tools we're going to get more comfortable with in scikit-learn. All right, so I got to head out. So everyone take care.